As my next Patreon goal, I chose to build a new CNC machine. Now the goal is about to be reached, and because it's a longer process, I thought I'd start early. My old CNC machine kind of served its purpose, but it used every opportunity to make trouble. That's because it had to fit in a tight budget. Thanks to Patreon money, I can spend more on the new one, but I won't insist. Instead, I'll try to make the best performer that's possible with mostly Chinese hardware. The Chinese are still eager to send me free samples for YouTube videos after all. And at a first glance, all of this stuff seems decent. But when the time comes, I'll test every component thoroughly and replace those that are insufficient. This first episode is about the Spindle motor primarily. It's a 3-phase brushless motor, the same technology that's used in quadcopters for example, but a little bit more powerful in this case. I went with this 1.5 kilowatt model intentionally, just because it's not the most common 2.2 kilowatt version. That'd be a real mass product with widely varying runouts, according to owners. This one has a specified radial runout of 0.01 mm or less. Must be my lucky day because I measured 0.003 mm on the inner diameter, which is fantastic. Apart from that, it's water cooled, which adds a little bit of difficulty but a ton of elegance to the system. Because I'm not planning to push this motor to its limits, I could use a small PC radiator. That'd be cute. A half-hearted teardown attempt has been made. But I gave up rather quickly, because there isn't going to be anything interesting in there anyway. Except for these internal cables, which are way too thin for 5 ampere, and have way too little isolation for the 220 volt, for which the motor is rated. It's probably fine for hobby applications, but I will take the opportunity and install an additional ground strap to this open connector pin. I'll connect that to protective earth, so that the residual current circuit breaker can do its job and protect the motor and me if something goes wrong. I would have preferred to replace the internal cables too, but further disassembly seems impossible without some sort of pressing tool. I guess I'll have to accept it as it is. Same goes for the connector. I don't think there's anything wrong with what they've delivered. But I would have loved to finally put this beautiful shielded motor cable and its $60 connector to good use. Here's what a $60 plug looks like on the inside. Wow. But I think the shielded cable would be too stiff anyway, because in the end I want to put everything in these drag chains. So I think I'm just going to use this random piece for preliminary testing. If I try to cheap out and use this cable in the final installation, you've got to call me out. For now I'll solder protective earth to my new ground strip and cables 1, 2 and 3 to motor terminals U, V and W. I'll make the same connections on the other side of the cable in a variable frequency drive. I am 99% sure that I've ordered a Huanyang VFD, which is the most common brand and is therefore supported by Linux CNC. But for some reason a YL620 arrived, which does exactly the same thing, but everything is arranged slightly differently. So if you're building along, take care and double check. That's especially important for the configuration bits, which have the same functions but all different addresses. I'll start with a factory reset to put this thing in a known state. And then I'll change a few motor-dependent parameters, which I'll explain on my website. Link down below. P4 to P10 are acceleration curve settings, for example. And P309 sets the front panel potentiometer frequency range. Because of the water-cooled Spindle motor, I don't have to worry about airflow. I can allow everything between 0 and 400 Hz. And this is the moment of truth. Magic smoke? Explosions? No, everything is alright. Ooh. The motor gets slightly warm because there's no water cooling yet, but nothing excessive. The final thing I want to prepare is some sort of software remote control. For me that's an important feature because it allows me to set the Spindle frequency in G-code. Almost exactly 2 years ago I made a video about that using RS485. Today I want to use a super simple PWM signal instead. I'll generate that using my Raspad. Did I mention the Raspad before? A very handy little Linux tablet. Their Kickstarter campaign is rolling right now, and I think it's worth supporting. But that's been all I wanted to say about the Spindle motor. What would you like to see next? Precise mechanical parts or extremely precise stepper motors? Let me know and see you then.